Welcome to trigonometry. This is my favorite part of the class. Today I'm going to review with you some basic formulas that you need to memorize for the next two chapters, and then we're going to find the values of the 6 trigonometric functions at 2 different angles, and finally we'll find the values of the 6 trig functions not given an angle but just given a point on the terminal side of the angle. So let's get started. The definitions of the 6 trig functions that I'm going to use are the following. Theta is an angle, x, y lies on the terminal side of the angle, and r is the radius of the circle on which x and y lie. So r squared is x squared plus y squared by the Pythagorean theorem. If that's the setup, then sine theta is y over r, cosine theta is x over r, tangent theta is y over x. Cosecant theta has two expressions. It's 1 over sine theta, and that makes it r over y. Secant is 1 over cosine, r over x. And finally, cotangent is 1 over tangent, which gives you x over y. You need to memorize those definitions. Sometimes we use alternate terminology. You may have learned this in maybe a geometry class in high school. If theta is positioned here, then the side opposite theta we call the opposite side. So that would play the y in the formulas on the previous page, and the side that is closest to theta is called the adjacent side, and hypotenuse is the hypotenuse of this right triangle. And so if you're using that terminology, then sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and so on and so forth. So sometimes I'll slip into that terminology, and if I do, that's what I mean. Now on a unit circle, r is 1, and so the definitions of the trig functions simplify simply to sine theta is the y value, cosine theta is the x value, tangent is y over x. But if you just need to memorize one set of formulas, if you're feeling overwhelmed, then go with the first set with the r in it, because those are the most general formulas. Alright, so you need to know that, and you need to memorize the reference triangles for 30, 60, and 45 degrees. These are on the unit circle handout that I have placed in the documents folder. The hypotenuse for each of my reference triangles is 1, and for pi over 4, which is 45 degrees, the legs have equal length, root 2 over 2. Pi over 6 corresponds to 30 degrees. The opposite side, that's over here, is the short side. That has length 1/2. The adjacent side of that angle is the longer side, which is root 3 over 2. And for pi over 3, those two sides just switch. The adjacent side is the shorter one, and the opposite side is the longer one. Memorize those, make flashcards for those, and you'll see how we use those in the next problem. Alright, so here's a problem. Find the 6 trig functions at 7 pi over 6. The first thing we want to do is draw that angle in the unit circle and label coordinates of the corresponding point, meaning label x and y. And we're going to use our reference triangles to do that. So here I have a unit circle, I've got my reference triangles lined up. I've got to find 7 pi over 6. Here's how I like to do that. Pi over 6 is 30 degrees. So I start at angle 0, which is over here, and I start going around the circle in a counterclockwise fashion till I get to pi, which is 6 pi over 6, and then I have to go one more to get 7 pi over 6, one more increment of 30 degrees. So that puts me at this angle right here, and to get the reference triangle, I drop a perpendicular straight from this point here to the x-axis. And that gives me the following triangle. Alright, so that's a 30-degree angle in here. So the opposite side is the shorter side, and the adjacent side is the longer side. And using my reference triangle for pi over 6, which is 30 degrees, that tells me that this length over here is 1/2, and this length here is root 3 over 2. Now I have to put the correct sign on these coordinates. I'm in quadrant 3, so x and y are both negative. X is negative root 3 over 2, y is negative 1/2. Now I have everything I need to write down the value of the 6 trigonometric functions. Just plug in to those definitions from the first set that I gave you, sine is y over r, negative a half over 1 is negative 1/2. Cosine is x over r. R is 1, by the way. I'm on a unit circle, meaning r is 1. Cosine is x over r, negative root 3 over 2. Tangent is y over x, which is negative root 3 over 2 over negative 1/2. The minuses cancel. And to divide two fractions, I multiply by the reciprocal. The 2's cancel, and I get positive root 3. And you can read the following three, the next three. The cosecant is negative 2, secant is negative 2 root 3 over 3, and cotangent is root 3 over 3. I think Course Compass wants you to rationalize all your values. So instead of writing 1 over root 3, you'd have to rationalize that as root 3 over 3. Let me just show you how to find one more reference triangle. For example, if you wanted to do 7 pi over 4, first you'd have to find the angle. Pi over 4 is 45 degrees, so we're going in increments of 45 degrees. Here I have pi over 4 right here. 2 pi over 4 is pi over 2. 3 pi over 4 is here. 4 pi over 4 is pi. 5 pi over 4, 6 pi over 4, finally 7 pi over 4. It's 1 pi over 4 increment short of 2 pi, which is 8 pi over 4. The reference triangle I'm going to use is the one for pi over 4, which has the legs are of equal length, root 2 over 2. I'm in quadrant 4, so I know that x is positive and y is negative. So the x coordinate is positive root 2 over 2. Y coordinate is negative root 2 over 2. You should get fairly good at doing this, and a good way to practice is to fill out the unit circle handout that I have in the documents folder. I have a blank version of this up there, so none of the angles are filled in and none of the coordinates are filled in. You just work with filling out the blank version, and then you can check your answer because I have the key online too. It's well worth your time to memorize the unit circle. All right. 2 more problems. This is going to be a long video. I apologize. You can pause it and take a break if you need to. Let's find the values of the 6 trig functions at negative 5 pi over 2. Now, that is a multiple of pi over 2, so I'm not going to use these reference triangles. I don't need them. This is going to be what's called a quadrant angle, meaning it lies on a divider between 2 quadrants. So the pi over 4, the pi over 6, the pi over 3, they're not going to help me. Let's draw this angle. When you draw a negative angle, you go clockwise. So you start at 0, that's the positive x-axis, that's angle 0, and you start moving in this case, clockwise fashion. We go to negative pi over 2, keep going, get to negative pi, then negative 3 pi over 2, and finally back down here to negative 5 pi over 2. So negative 5 pi over 2 shares a terminal side with negative pi over 2. They lie in the same place. The coordinates of this point right here are x equals 0 and y equals negative 1. Again, I'm on a unit circle, so the radius of that circle is 1. So my coordinates are 0, negative 1. And now the easy step, just fill in the values of the trig functions using the definitions. Here we are. Sine of negative 5 pi over 2 is y over r, negative 1 over 1. Cosine negative 5 pi over 2 is 0 over 1. You have to know that 0. 0 over 1 is 0. Whereas with tangent, tangent's y over x, negative 1 over 0 is undefined. You can't divide by 0. So tangent of negative 5 pi over 2 is undefined. Cosecant of negative 5 pi over 2, there's a little typo there, that 6 doesn't belong, is negative 1. Secant is r over x, which is 1 over 0. Again, that's undefined. Cotangent is 0 over negative 1, which is 0. Okay, hang in there. One more problem. Find the 6 trig functions at theta, and we're given a point on the terminal side. The first thing we have to do is determine what quadrant we're in. If x is positive and y is negative, we have to be in quadrant 4. So we're just going to draw a generic angle in quadrant 4 and label the x and y coordinates appropriately. we're going to label x as positive 24, y as negative 7. So the length of this leg of the triangle is positive 7. The length of this is 24. I can use that together with Pythagorean theorem to find out what r is. That gives us r squared is 24 squared plus 7 squared, which comes out to be 625. So r is positive the square root of 625. R has to be positive because r is the length. R is the radius of this circle here. R is the radius of the circle. That's a positive number. So r is positive 25. So we have r, we have x, we have y, we have everything we need to write down the values of the trig functions. Okay, so here we go. Sine theta is y over r, which is negative 7 over 25. Cosine theta is x over r, 24 over 25. Tangent theta is y over x, which is negative 7 over 24. And then cosecant, secant, and cotangent, you just flip the three fractions above to get those values. Okay, that's it. In the next section, we will do some more challenging problems. For now, memorize your unit circle. Bye now.